This is Mike Biel, and today we are going to walk through lab exercise 2 for experimental stress analysis. In this lab, we will look at the calibration of a strain gauge and the calibration of a strain indicator, and we will consider the case for a quarter bridge configuration using a 3-wire configuration. First, for the strain gauge calibration, we will take the strain gauge that was applied in lab 1 and we will measure its resistance, including the 24 inches of lead wire. Next, I will provide a simply supported arrangement for the beam. It has a 6-inch span, just using a bench vise. The strain gauge beam will be placed over the vise with the gauge at the midpoint between the two supports. So here is our test setup with our Vichet strain indicator. 3 sets of measurements were performed with 3 different gauge factors. The gauge factor of 1.5, the actual gauge factor as reported by Vichet for the strain gauge of 2.13, and a gauge factor of 3.0. Here is the strain gauge indicator with the gauge connected in a 3-wire configuration, and it is balanced and ready for measurement. And the gauge factor of 3.0 is selected on the gauge factor knob. A series of masses will be applied to the hanger and then hung from the center of the beam. Here is the load applied to the beam, and then the strain is measured with the strain indicator. This is performed for about 6 or 7 different load steps. The target is to achieve a maximum strain of about 700 microstrain. Here's the maximum load of about 732 microstrain. However, that's reported with a gauge factor selected of 3. And now we can see the relationship between indicated strain as a function of the theoretical strain from a calculation using the beam dimensions and the applied loads. And then you can see for the black curve with the gauge factor of 2.13, there's still about 5% error. So the lead wire resistance does change the gauge factor. Next, we'll calibrate the strain indicator. This will be performed using a shunt resistance technique. So 5 shunt resistors will need to be identified. So for the simulated strains, we can then calculate what the target shunt resistance should be. Here's a measurement of our first shunt resistor. It's a nominal 330 kilo ohm resistor. Here's our second shunt resistor, the third, the fourth, and the fifth. The actual resistances are shown here along with their theoretical strain. So The shunt resistor is applied across the P positive and signal negative terminals. And this shows how that was done. And so lastly, we can plot the indicated strain from the strain indicator versus the theoretical strain for that shunt resistance. And we can see there's about a 1.25% difference.